we're going to look at two more applications of trigonometry that are still going to use our solving right triangles, but not the entire triangle. And so the two applications we're going to look at are angle of elevation and angle of depression, and then we're going to take a look at distances and bearings. So angle of elevation is basically what it suggests. We're looking up at something, or maybe something is moving uphill at a certain rate, but the angle of the elevation just suggests what angle we're looking up or something that is, increasing, etc. Now, angle of depression is we're looking down or something's moving downhill at a certain angle or something of that nature. Right. So, a couple examples. So we have the tallest television transmitting tower in the world is in North Dakota. From a point on level ground, that means 5,280 feet from the base of the tower, the angle of elevation is 24.4 degrees. We want to approximate the height of the tower. All right, so here is some stationary point on the ground. And then let's say this is our tower. All right, so don't judge me. And then our distance from this stationary point on level ground. All right, so this is going to be from here to here. This is 5280. All right, now we have an angle of elevation. Okay, and this is going to be 24.4 degrees. And so what we're looking for is we're looking for the height of the tower, which I'm going to call x. Right? Now, we know an adjacent side, we're looking for the opposite. And so we know that the tangent represents the relationship of opposite to adjacent. Okay, so we can set up a relationship. The tangent of the angle, which is 24.4 degrees, is going to be equal to the opposite, which we called x, divided by the adjacent, which we said was 5280. Then I'm going to multiply both sides by 5280. So 5280 tan of 24.4 degrees equals x by multiplying both sides by this. And then we can just shove that into our calculators. All right, so making sure we're in degree mode. So we have 5280 tangent of 24.4, and that gives me to the nearest foot 2395. Okay, so that would be 2395 in feet is equal to x. Okay, so it says the nearest foot. All right, a second example, we have a helicopter hovers 1,025 feet above a small island. All right, the figure shows the angle of depression going down this way is to the coast is 40 degrees. So how far off the coast? Okay, so how far is this distance d? One thing to note is that from this perpendicular right here to here is a 90-degree angle. And so if we know that this is 40, the remainder of the angle is going to be 90 degrees minus 40 degrees, or 50 degrees. Okay? And so that's the angle that we're working with. So if we just take a cross section of what we have, okay, this is really a 50-degree angle. We know that this is the distance d we're looking for, and this is 1025. And so once again, we have an adjacent side, we have an angle, and we're looking for the opposite side. So we could just use a tangent function to model that. Okay? Because remember, tangent is opposite over adjacent. So we could say that the tangent of 50 degrees is going to be equal to the opposite, which is d, divided by the adjacent, which is 1025. We can multiply both sides by 1025. Okay, so 1025 tangents of 50 degrees is equal to d, our distance. And then to the nearest foot, let's just shove this into our calculator. So we have 1025 tangent of 50 degrees, I think it was, right? And so that's going to give us 1222 because the 0.5 rounds it up. So, excuse me, that's 1222 in feet is equal to our distance d. Another thing we should be looking at is bearings. Okay, so we want to find these bearings, and the way bearings work is that we always go north or south first. Okay, then we go east and then west. All right, and so if we're looking for our bearings, the way we write it is we write north blank east, okay? That tells us how many degrees north and east, okay? So we would say north of east, or we might have south of east, or we might have south of west, or we might have north of west. And these would be like your measures inside of there, right? We always want to stem off of the y-axis, okay, for our angle. So for instance, over here, if we're looking for the bearing from O to A, the 62 helps us a little bit, but remember, this is a right angle. And so to find the actual angle, north of east in this case, that would be 90 degrees minus 62 degrees, or that would just be 28 degrees, okay? And so the way we would write this, we would say go north first, and then we're going to go east 28 degrees. So north 28 degrees east. Okay. In the second example, this one's done for us, okay, because it's already, the angle is stemming directly from the south. So the way we would write this one is south 74 degrees west, okay? So always start with north or south when you're doing these directional bearings, and then you go east or west, okay? So y-axis first, then the other way. So an application of that, we have a forest ranger sights a fire directly to the south. A second ranger 9 miles to the east of the first ranger also sights the fire. The bearing from the second ranger to the fire is south 25 degrees west. How far is the first ranger from the fire? All right, so hopefully it's not too big of a fire since you're seeing that it's 9 miles away. So let's call this guy right here. Let's call him Ranger 1, right? And then 9 miles east. Okay, so if we have like a coordinate plane, okay, here's our second ranger right here. Okay, so this is be Ranger 2. All right, so this is our west, this is our south, this is our east, and surprisingly, that's our north. All right, now Ranger 2, it says 9 miles here, and they spot the fire, right? So it's directly south. Okay, so the angle is going to be south of west this way. All right, so that is going to be 25 degrees. Okay, we're trying to look for this fire. Okay, so I know that's not a good drawing there. All right, but that's what we have. Okay, what we're looking for is the distance of Ranger 1 to the fire. Okay, so we're looking for this south. Right. Another way to think about this is that if this is 25 degrees, then the remainder, this angle, would be 90 minus 25. Okay, so 90 minus 25 is going to be 65 degrees. Okay, so this is 65 degrees. And what we're looking for, and we have 9 degrees as adjacent, and we're looking for the opposite, which is going to be the south. Okay, and so what we can do is we can use just a little bit of our trigonometry. We can use our tangent function, and we could say the tangent of 65 degrees is going to be equal to the opposite, which is the south, divided by the adjacent side, which happens to be the 9 miles. We multiply both sides by 9, so 9 tangents of 65 is going to be equal to the south, and then we can just throw that right into our calculator. Okay, so we have clearing 9 tangents of 65 degrees. 19.3 seems to be the distance in miles. Okay, so this would be 19.3 miles south. All right, so that's a long way away. Hopefully the forest ranger doesn't have to walk that fire, otherwise bad things might happen. All right, so that's everything that we need to know about our bearings as well as some of our distances. In our final video series, we're going to take a look at simple harmonic motion and how we can use trigonometric functions to model that.